Assalamualaikum warahmatullahi wabarakatuh, everybody. Welcome to another video of CSE 221, and today we'll be dealing with codes. Many of you face problems with CSE 221 codes. So 221 is basically an algorithm course, and you don't need to code unlike CSE 111 and 220. However, in the 221 lab recently you have 35 marks, so it's very important to know the codes, and the coding problems in the 221 lab is pretty tough. So many of you face problems with that. So I decided to make 3 or 4 videos about codes, just codes. Well, I'll not write the code over here because they are very lengthy, so I already have prepared them. These are my own codes, and I'll show it to you and explain the code step by step, and maybe I'll even upload it. It's my code, so there's nothing about copywriting or something, and I'm not gonna like hold you accountable for why did you copy my code. I don't care about that. So you can use this. So I'm going to explain this, and one of the things that makes a difference in 221 lab is that you're told to use Dr. Java, NetBeans instead of Dr. Java. So you say a pretty sad goodbye to Dr. Java, which was pretty easy and simple to control, and you open this NetBeans and you see all kinds of stuff, and you're like, what do I have to do to make sense out of it? So one of the basic differences is that you cannot now just create a normal class. You have to create a whole project. So you see this new project thing, you go there and you go to Java and then pick next and then click a name, and this will automatically create a main class for you according to the name of the package, and that will also include this public static void and everything. So you need to work in packages in NetBeans because the real programs are created in packages. You don't use a program with one class generally. So that's all for NetBeans and normal introduction. Let's get straight to the work, and today we'll be dealing with sorting, even though it would have been better to start with the adjacency list, but this is a 220 stuff. So let's get this sorted, and of course we'll also have to work with the sorting of graph. And I'm sorry about the background noise, I can't control it. We're in a very noisy country after all. Anyways, so we have this public static void method, and there are lots of stuff over here. Like some of you may get confused at what is all this stuff. So I'll pretend that you don't know. Even if you know, it's alhamdulillah. If you don't know, then let me show you. We have this size variable. The user will give us a size, and we will create an array according to that size, which is a 110 stuff. Then the user will give me a number, and I'll put that number in choice. It could be 1, 2, 3, 4, or 5. If he if he or she inputs something else, I'll tell you that. And we have an array which is empty, sorted. Now back to that choice. If she inputs or he inputs 1, then we'll use bubble sort. We'll use 2 methods that I made, print array and reverse print array, and you can see the array printed from forward and then a backward one, and the array will be put in this sorted variable which will hold an array, and in this way all the sorting will happen depending on what number the user inputs. So we'll be looking to 5 types of sorting, sorry 4, no 5. Anyways, and default cases, for example, the user is crazy and he's like, what if I write 6 or 7, and in that case then the Java will use, okay fine, that doesn't exist, so I'll just do bubble sort. That's default. You need to have that in switch. And these are the 2 methods, printing array from the forward, from the backward. That means from 0 index and from the last index. Simple formulas. Anyways, let's start with the bubble sort. Let me get my pen, and the color today will be green. Here's my funky pen. Anyways, so bubble sort, which is one of the most easiest and the most simple sort you might find. As you can see, there is a variable temp over here, and we have a for loop. So suppose there is an array 1, 2, 3, 4. Let's just keep it 4. Oh, it's sorted, so we'll have to mess this up. 5, 6. So this is 6. Now what bubble sort does is you start a for loop which will go from index 0, that is 5, and it will go until it reaches 4. And every time you reach an index, that means another for loop will run, which will run from the next index. So if you are in 5, the next index is 6, which is 1, 0, 1, 2, 3, 4, and 5. These are your index numbers. So the first for loop is here, and so the second for loop will start from here. Okay, and if xi, which is 0, is greater than xj, which is 6, no, it's not greater, so we'll just skip that. So the next for loop will then go to 1. Is 5 greater than 1? Yes, it is. So that means I need to keep this 5 in temp, which was 0 now it has 5, and then the position of x, this one, will have this number. That means 1 will be here. Okay, and so if 1 is here, then this, both of them are 1, and my 5 is lost. So that's why I had a temp variable. Otherwise, if I didn't have this, then 5 would have been lost. So that's why I have to store 5 in another place, which is temp, and I bring 1 over here, and then I put 5 from temp to here. So now basically the array just became like this, 5, and this is 1. Just imagine there is 1 over here. Anyways, and then the same thing will happen for 2, 3, 4. 5 is greater than all of them, so kind of like 2, 3, 4, and then it will be 5 over here. And in this way, then the next thing will happen for 6, and in this way the whole array will be sorted. That's how bubble sort works, which is pretty easy. And as you can see, there are 2 for loops over here. So if there's a matter of time complexity, this one will have n and this one will have another n, and so 2 of them would make an n squared. Okay, so order of n squared, that will be your time complexity, one for this, and this is a nested for loop. Okay, so this for loop is inside this, so n star n, and this one is simply order of 1, this one is also order of 1, so we'll ignore them and get this n squared. Anyways, now some of you are thinking, oh great, sorting is very easy, let's go with bubble sort, I don't need to know any sort. But unfortunately they won't let you use bubble sort in the lab. Yeah, I'm really sorry. This is how probably you're feeling like, what is wrong with them? Anyways, it is because the time complexity of bubble sort, and it's very easy, and that is why they will not let you do this. So they might allow you to do insertion sort, which has the same time complexity, because as you can see there's a 4 over here, and with that 4 there's a while, so it's kind of like the same, n star n, which gives you n squared, order of n. This is order of 1, this is order of 1. It's almost the same thing. Well, the only difference is that time you did 4 loops, and here you're checking with a while loop. It's actually, at the end of the day, it's the same old thing. You're inserting by checking all the numbers at once. That's the same thing. You were working in an array, and now you're just inserting in a pretty decent way. So you all know about insertion sort. So I'm not going to spend some time over here. You can kind of understand the code, and you already know this. And there's a possibility that they won't allow you to do this. So let's just get straight to merge and the ones that are necessary. Okay, drawing off, and we have merge sort. I have already explained how merge sort works in a video of sorting, so I'm not going to spend my time explaining how sorting is done. Let's rather just get to the code. So you know that you will have to divide the array into multiple segments, and we have 2 various invariables over here. One is n1 and one is n2. First you can say, okay, what is this m, l, what are these things? M is for the middle, r is for the right, l is for the leftmost, and array is the array. Okay, if you can provide custom variables, or if you want an array, then this is the 0 index, this is the 0 plus array length divided by 2 index, and this is the last index. Anyways, so m minus l and plus 1, which will actually give you the index which is in the starting point, and r minus n, which is the last index, minus the the middle, which will put you at, if you have an array of 1 0, say 1 0 1 2 3 4 5 1 2 3 4 5 6, so this could be the middle, and you will get something like this or this. So we'll divide these arrays into multiple arrays. As you can see over here, we have 2 arrays for division purposes, and this will be formed according to n1 and n2. As you can see, we are dividing them. Now this part will be my first array, this part, and this part will be my second array. So n1 is kind of like 0 to 3, 0 to 2, and n2 is kind of like 3 to the last index. And that's how we'll deal with this size. So the value of, since for this array, since they're all equal, both of them are 3, but had it been something like this, so one side gets more, then n1 would have been 0 1 2 3, n1 would have been 4, and n2 would have been 3. There would be a difference of 1. And if the array size is equal, for example 6, which is divisible by 2, then they will have the same variable, sorry, same number, value 3. That's how the division is done. And now we will have to also input the values. I keep telling them variables, I don't know why. So you have to put the value. Okay, and guys, in case you're just getting any ideas, there is someone else in this room, so don't think I'm making the video in the toilet. Okay, so let's go on. And int I, this is another variable which is 0, and j is 0. I need 2 of them because I need to sort out them separately in the arrays, the new arrays, as you know from the video where I described sorting, that once we divide them, we keep dividing them, and then we'll eventually have to sort them. So for that, this division continues in this part. You see I is 0 and j is 0, and if they are greater than n1 and n2, and as you might remember, for the array we did, both of them are 3. So yeah, definitely 3 is bigger. So then we'll create another arrays, which will not create arrays actually. Well, remember, this is a recursive thing, so this is for one array. For example, if my array was something like 0 and 1, only 2 indexes, then this will just run one time. And for that, here, this is the part where you do the swapping. So if in the 0 index you have 3, and in the 1 index you have 4, then it's fine, you don't need this. But if the opposite happens, then you need to change the number, and you need to put 3 over here and 4 over here if it was 4 or 3, right? So that's why this happens, and this thing will happen as long as all the numbers are not sorted. And that's how these while loops are working. If I just explain all of them, it will take a lot of time, but if you still face problems, let me know. I can explain, of course, but if I really go through every single while loop, it will take a lot of time. Now I'll let you explain this part. Okay, like I told you that this is a recursive process. So merge sort will happen for the array once, and then from middle to the second part. So we are dividing the array already when we are about to start this process. And then again, as you can see in the process I showed you above, the array is created, 2 new arrays are created, and they are divided. So actually you can see here 1 array, 2 array, 3 array, 4 array. Already we divided it into 4 parts. Now if it's necessary, then this whole merge sort process will divide the arrays, and it will be 8 arrays, and in this way they will be divided. This is the like awesome thing about recursion, that they do their stuff if it's necessary. And if you have an index like 2 or 4 or 8, then it's done in 2 or 3 processes. And then finally you will use this merge method above to do the merge sort for this one and merge sort for that one, and this will go on until the index numbers are satisfied. And then finally just sort them all out using the merge method. That means you will have to join them after doing all kinds of sorting stuff. So that's how you do this. So actually this part is just for breaking and arranging, and the part above that I showed you is the part that deals with the swapping and checking. That's all for mark sort. Now we'll move to quick sort. Like I said that I can't explain what they are. I already did in a video before. Now I'll just show you the code. Now we'll be dealing with quicksort. So we have to take a random number over here to choose the pivot, and after you choose the pivot, then you have two work. Like from the pivot you have to sort the left part and the right part. So we take this part, as you can understand, is for checking the right part, and this part is for dealing with the left part, and we will be dealing with index numbers. We'll store the numbers and we'll do simplified swapping of the numbers using a recursive like process until the index numbers are behaving properly. And simply you can just use this pivot thing for the left part until the L, and from R to the right. That means I'll just show you. Probably everything doesn't make any sense with this. When you come to this, you have 0, 1, 2, 3, 4, 5 indexes. Okay, so 6 indexes. Maybe this is your pivot. So you deal with this part and you deal with this part. Once you sort them out, and the pivot, first thing you do is with this part, you choose the pivot to the right place. That will be done above, and then again choose a pivot. This part, this quicksort will deal with this part, and this quicksort will deal with this part. So again they will find a pivot. For example, maybe it's 4 over here, maybe it's 1 over here, and then the pivot will be sorted and the rest of the array will be sorted. Very easy to understand. Just choose a pivot and then sort the left part, sort the right part, then do this again for the left array, do this again for the right array. Very easy, and the code is also very easy, as you can see. But if you still face problems, let me know. And guys, I'm really sorry for the noise. I have nothing to do about it really. And lastly, you start with heap sort, which is very easy if you just understand how it works. All you have to do is heapify, and you know, I have commented out the heap sort part because I'm really kinda busy, and you can see this is a great code from Geeks for Geeks. You can use that website to do any kind of code you need. I love their codes. They make pretty easy codes. So if you understand this one, it's just as easy. But I recommend that you go with merge and quicksort, especially quicksort. The code is very easy to understand. My intention was to do the quicksort one only, you know, but I decided, okay, why don't I give you guys all and you pick your one. Heapsort is pretty easy to understand. I have like edited some things for you, commented out these things. Some were done with the website and I did some modifications. So you have this whole sorting thing, and I will upload it on the online file so that you guys can make good use of it. I'm sorry for the noise, and I hope I was able to do some good to you guys who were facing problems with sorting. The intention of the video was to help you with sorting, but I gave you some noise and annoying breaks instead. I hope you like it. I hope I was able to help, and for the sake of all these problems, I'm uploading this code and it will be available. You can use it. Just use it to sort, and anywhere you can use this same algorithm to sort your graphs, arrays, linked lists. Just modify the stuff. Thank you. And also, yeah, don't forget, happy surviving.